Welcome to today's tutorial. In this video, we're going to explore a fascinating and highly relevant topic: implementing face recognition technology for classroom monitoring. This is crucial in ensuring the safety and attendance of students and educators alike. We'll walk you through each step, from setting up your environment to coding and testing the face recognition system. Let's start by outlining what we'll cover in this tutorial. We'll break it into sections: setting up the development environment, understanding the face recognition library, implementing face detection, capturing video streams, and finally, integrating it all into a classroom monitoring system. Before diving into the coding, make sure you have Java Development Kit installed on your machine. Additionally, we'll leverage an open-source library called OpenCV for our face recognition tasks. OpenCV can be a bit challenging to set up, so listen carefully as I guide you through these steps. To begin installing OpenCV, head over to the official OpenCV website. Download the latest release suitable for your operating system. Once downloaded, extract the files to a convenient location. We'll now add the OpenCV library to our Java project. Next, let's ensure our project is set to load the OpenCV native library. In our main application class, we need to set the library path in order for our Java application to find the native OpenCV DLL files. Now that we have OpenCV set up, we need to capture video input. We'll be working with a webcam for this. Let's create our main class and begin with the code to initialize video capturing. In the code snippet above, we import necessary OpenCV classes, initialize the webcam, and create an infinite loop to continuously read frames from the webcam. Next, let's add a feature to display these frames. Let's run this code and ensure that we can see the live feed from our webcam. You should see a window popping up showing the video stream. If the video feed isn't working, double-check the camera permissions on your operating system. With video capturing in place, our next step is implementing face detection. OpenCV provides a pre-trained HAR cascade classifier for this purpose. You can download the classifier file directly from the OpenCV GitHub repository. After loading the HAR cascade classifier, we invoke detect multiscale on the frame retrieved from our webcam. The result will be a collection of rectangles that represent detected faces. Let's refine our code to draw these rectangles on our video stream. Once you run the updated code, you should observe green rectangles highlighting the detected faces in the webcam feed. This is a significant milestone in our classroom monitoring system. But we don't want to stop here. Face recognition takes this a step further. Next, we need to implement face recognition. For this, we'll leverage another OpenCV feature called eigenfaces or Fisher faces. Initially, we'll need a data set of images of the students present in the classroom. Let's create a utility class for managing face images. This utility class will help us train our face recognition model with face images and then use it for predicting the identity of detected faces. In our classroom, we can collect individual images of each student, label them, and store them for training our face recognizer. Once the images are collected and the recognizer is trained, we can integrate the recognition process into the webcam feed. For each detected face, we will predict its label using our newly created face detection util. Incorporate this code into the main loop where you're displaying the video feed. As a result, when a student's face is detected, it should print out the corresponding label of that student. This functionality allows the educator to monitor attendance and identify students in real time. Let's step back for a moment and examine the potential use case here. With this implementation, you have a robust system to keep track of attendance while also ensuring that unauthorized individuals aren't present in the classroom. The efficiency and automation can dramatically improve monitoring protocols in educational settings. Before concluding today's session, I encourage everyone to experiment with optimizing the parameters of the face detection and recognition algorithms. You can dive deeper into enhancing accuracy, such as adjusting the training dataset or exploring different face recognition techniques. As we wrap up this tutorial, let's briefly recapitulate what we've accomplished here today. We learned to set up a Java environment with OpenCV, captured video from a webcam, implemented face detection, and finally integrated face recognition into our classroom monitoring application. I hope you found this tutorial helpful. If you did, please give it a thumbs up and share it with others. Don't forget to subscribe to our channel for more intriguing programming tutorials, and hit the bell icon to stay updated on future content. Happy coding, and see you in the next video. Goodbye.